Hey everyone, I'm Shashank at AWS, and in this video we'll take a closer look at Amazon SageMaker Inference Recommender. If you've gone through the process of model deployment, you probably spent a fair bit of time trying to figure out what the right instance is for your model deployment. There are many different CPU and GPU options on AWS, and they come in different sizes with different number of vCPUs on each instances, but also different number of GPUs on each instance. Now you may have a specific target throughput or latency need, and in order to find that sweet spot combination between the instance type, the cost of the instance, and the throughput and the latency requirements that you have, you've spent probably days, hours, or weeks trying to figure out what the right one is for you. If you haven't, then you're probably not using the most cost-effective instance for your workload. SageMaker Inference Recommender solves that problem for you by automatically benchmarking your models on a variety of different instances, fine-tuning it, and finding the best cost and performance ratio instance for your workload. In this video, first we'll take a look at some of the concepts behind how it does this, and then we'll take a look at a code example where we'll go through how you can set up an inference recommender job, submit a job, and get a result, which is basically a summary table that tells you what the cost per inference is, what the throughput, what the latency is, and it'll automatically generate this result for you so you can pick the right one without having to go through setting up your own test harness and setting up your own testing framework to do that. So let's jump right in. As I mentioned earlier, you probably care about three things. Throughput, which is how much requests can you process at a given time. This could be number of customers that are hitting your endpoint at the same time, or how much traffic you're processing at the same time. The second thing you probably care about is latency, and typically we talk about round trip latency from the client to the inference request and getting back the results. And this affects user experience, especially if you're building something like a conversational AI, for example. Then if you don't have sub 10 millisecond latency, then you're not delivering a good customer experience. And for other applications, your latency budget may be a little lower, but in any case, you need to have some tight latency which delivers a good customer experience. The third consideration, of course, is cost. Can you deliver your desired throughput, meeting all the customer requests at the desired latency within the budget that works for you? Okay, you want to be able to find an instance that can satisfy all these three criteria. Now, if you've gone through the different instance options at AWS, you know that there are many different options, from CPU options such as your T instances, your C instances, your M instances, and then you switch over to GPU options with P instances, G instances, also the Inf1 accelerator. All of these are great options depending on what you're trying to achieve, and each of these again come in different sizes. You have large, you have extra large, and so on, right? If you take a look at all the different combinations, and that's sort of a combinatorial explosion here. Specifically if you want to measure throughput and latency and cost for all these different options, just imagine having to go through, set up a testing framework, taking your model, running it on all these different options, and not to mention the fact that you need to be able to simulate different traffic patterns as well. Thankfully, we have SageMaker Inference Recommender that will do all of this automatically for you. So how does it work? Well, you have all your options that we discussed previously, and they of course come in these different sizes. Now, the first thing Inference Recommender will do is ask you for your model and a sample payload, and it can run a default recommender job. A default recommender job will simply just give you results based on some of the testing it does. So you don't need to provide any specifics about the traffic pattern and all that. This is your simple, easy to use approach. Just give your model your payload, submit a default recommendation job, and you'll get a table with results on the throughput, the latency, the cost per inference. Then you can pick the best instance for your model. But we understand that you may have very specific traffic needs and very specific throughput and latency considerations. Then you can run an advanced recommendation job where you can specify traffic patterns. For example, how many initial number of requests are coming in, how many requests you can spawn over time, and also add in stopping criteria for throughput and latency. That way you will be able to generate a recommendation list that works for your application. Okay, so that's the theory behind how this works. So how do you use it, right? If you're using SageMaker, or if you're used to using SageMaker, you know that you have to provide your model, which you can actually create an endpoint configuration and create an endpoint without having to go through a recommendation option if you already know what you want. Okay, if you don't know what you want, with Inference Recommender, you provide your model and then you specify a sample payload. Now this should be representative of the requests that are coming in. This could be images or signals or whatever it is. So a sample payload is used to simulate your traffic, right? Or the SageMaker Inference Recommender will use it to simulate your desired traffic. Next, what you want to do is register it with a model registry. If you're new to model registry, if you haven't used it, it's a great way to bundle not just your model but also several metadata like this. You can bundle the framework information, and specifically for Inference Recommender, there are two new options here. Domain. If your model is in the computer vision domain or natural language processing domain, you can specify it here. The Inference Recommender will use this information to generate those recommendations. You can also specify the task at hand. Task is whether it's a classification problem or a regression problem. There are a number of different task options that you can choose. And of course, you need the payload, and in the model registry, when you register your model, you also specify where the payload is. So all of this is encapsulated with this model registry, and you take this as an input to the SageMaker Inference Recommender job, and you submit a job. Okay, the output of this job is a nice little table, which, as I discussed, will tell you your throughput, your latency, your cost per inference, your model, and also how many instances you need in order to reach those kinds of throughput and latency requirements. And with a click of a button, you can deploy. Okay, you can host an endpoint directly with a click of a button on the instance that came up as a recommendation. You can pick one and deploy. Okay, so that's the theory behind it. Now let's jump into a code demo and see how this works. Okay, what I have here is a Jupyter notebook where I have a code example that goes through the process of submitting a simple default recommendation job and also an advanced job where we can provide other additional specifics such as traffic pattern and stopping criteria. This is running in SageMaker Studio, but of course you can run this on any Jupyter notebook where you have your SageMaker SDK and Boto 3 SDK installed and you have access to AWS. Okay, but the simplest and easiest way to run this is on Studio, and I'll show you why some of the results can be visualized directly within the Studio interface. So let's start by loading in some of the default packages. You need SageMaker. We have TensorFlow here because I'm going to download a trained model as a starting point. Okay, I'm going to download the ResNet 50 model as a starting point. We'll use this model to deploy and find the right instance for this specific model. So after I download the model, what you want to do, and this is standard SageMaker workflow, which is to take the model, build a tar file, upload it to Amazon S3 so that SageMaker knows where to get the model from. So I'm going to do that as a next step. So it's gone through the process of downloading the model and then generating this tar file, which you should see here on the left. This is the tar file that we upload to Amazon S3. Next, what we'll do is generate some payload data, and as I mentioned, this is the data that is representative of the requests that come in. I'm going to download 5 different images here. We can quickly take a look. These are images of animals here because these are things that the ResNet 50 model can predict on. right? So I'm going to download this, and same step, I am going to package them up as a tar file and upload them to Amazon S3. So both my model and my payload archive files are in Amazon S3. Next step is to figure out what the domain and task is. So SageMaker Inference Recommender offers different options that you can choose. Now these are optional, you don't have to choose them, but if you choose them, you can get better recommendations. So the example domains are computer vision, natural language processing, or general machine learning, and then example tasks are classification, regression, object detection, other if you don't know, or if it's something different, and then of course example models such as Resonate, YOLO, XGBoost. And if you don't have a model that's in this list, you can choose the closest one. Now what I'm going to do is query for a list of these metadata, and you'll see here that these are the different domains, these are different frameworks that are supported, these are different tasks, models, and framework versions. Okay, now if you don't know the specific information, you can skip it, but providing it is going to help get better recommendations. Next, I'm going to specify the container image that Inference Recommender should use. This is your serving framework. This is a framework in which it's going to run on these different instance types to get the recommendations as a result. Okay, so I'm going to provide instance type as a CPU instance type so that the container has software that's mostly for CPU inference. But if you wanted it to cover GPU, you would just replace C5x large here, maybe with a P3.2x large. Now the only reason you provide this is so that it pulls the right container. This is not going to affect the instance sweep that the inference recommender is going to perform. This is mainly to inform where the container image is, which happens to be TensorFlow inference serving container. Okay, so moving on, as we discussed, the next step is to register your model. Okay, and we'll go ahead and generate a unique ID here and create a model package group. And after we create a model package group, we'll create a model package. Now this model package is your model plus the metadata we discussed. Okay, your model is your Resonate 50, and we'll provide this as part of this API right here, S3 model path. And then we also provide the framework version and other metadata, the container image, which is your serving framework, and the additional features that were added specifically for Inference Recommender are the task and the domain. Okay, if you know this information, you want to provide it here, which is whether it's a classification regression problem, and the domain if it's computer vision, natural language processing, and so on. Okay, after you do that, you create your model package. The next step is to submit a default recommended job. As you can see here, it's super straightforward. You don't have to provide any additional information for your default inference recommendation job. All you have to do is specify the model package that you just created. Okay, model package, that's it. Because the model package has all the information, metadata and all that, the inference recommender job will just borrow the information about the framework, the model, the task, the domain, the container and all that, and go ahead and execute this job. Okay, just by running this, I can kick off a training job. This will take quite some time, because it's going to download the container and your sample payload and test it on a variety of instances. Okay, it's going to cycle through all of this, and it's automated. You don't have to do it. Inference Recommender is doing it for you. Okay, now rather than going through this now, it'll take a couple of hours. I'm going to stop this, and I've actually run this job previously. I'm going to query the results from this job. Okay, so the way to do that is provide the job name and I will say describe inference recommended job for a job that I already ran previously. And let's take a look at these results. You'll see here that what I have is a nice looking table that is giving me the instance type right here. So this includes, these are the recommendations that's come out of the default recommendation job. So there's C5, M5.2x large, M5 4x large, M5 x large, and C5 2x large. Okay. After sweeping through all the different options, it summarized these. Instance count, just one instance count. Here's cost per hour, and cost per inference, which is cost per inference based on the number of requests you can process. And maxed invocation is of course your throughput, and model latency, so how many milliseconds it took to process that request. Now if you're sensitive to latency, what you want to do is sort this. It's already sorted by model latency. If you're sensitive to throughput, not so sensitive to latency, maybe you can sort this by max invocation. Pick the one that's able to do this, but latency suffers. And maybe you're just cost sensitive, so pick the one that's cheapest cost per hour. Okay, and if I sort this, the cheapest option here is the MLC5x large, which gives you pretty good results with this throughput and this latency. Okay, so there's another interesting way to look at this. This is of course querying it here. So I'm going to copy this job name. If you're using SageMaker Studio, you can head over to this option on the left pane, and under drop down choose inference recommended jobs, and I'm going to search this specific job. So you see here that the inference recommended jobs are listed here. I'll double click on this, and you get this visual way of taking a look at the same information, right? And here again you can choose what is important to you, whether cost is important to you, or latency is important to you, throughput is important to you, right? So depending on what options you choose, you may see different recommendations here. And the table, or a version of the table, is also shown here at the bottom. And the cool thing is you can create an endpoint right here by clicking on this button here, specify and create an endpoint. That's pretty cool, right? You pick the right, it shows you the recommendations, you pick the right instance and then deploy. Okay, so that was a default job where we didn't really specify traffic patterns or target latency or throughput. Now let's take a look at a custom load test where you can go crazy with all the specifics. You can start by specifying, again, this is similar to the default job where you create inference recommendation job, but we provide a number of other information here. For example, I am asking this specific job to sweep these different instances only. So it's going to traverse through C5, G4, and P3 only. Okay, you can give a list of instances that you want it to cover. You can also specify resource limits, how many tests to run in parallel. This of course depends on what your resource limits are on your AWS account. And then you can, this is interesting, this part is interesting, which is traffic pattern. Here you can specify number of initial requests coming in, how many requests to spawn every minute, how long the traffic pattern should run, right? So you can specify these traffic patterns to simulate your real world use case, and stopping criteria. So you can specify your max throughput and also latency threshold. So if you're sensitive to latency, for example, you're building a conversational assistant and that real-time conversation latency is low, right? It has to be under 10 or under 20 milliseconds so that the bot feels like you're actually talking to it. Not if you're waiting like 2 minutes to hear a response, then that's just not a good customer experience. So you can specify your target here, say 20, and after that you go ahead and run this cell. Again, I won't run this because it takes a couple of hours to do this, but I have a job that I already ran. So I ran two different jobs here, one for latency 100, the other latency 20. Let's take a look at the result here quickly. So this is my table with the results. So it sweep through my different instance that I requested, which includes like the CPU as well as the GPU instance types. And you see here it automatically also tested it for to reach my target throughput and latency needs. It had to increase the instance count too. So it needs more instances to reach my throughput needs. So it's scaling out. And I take a look at cost per hour, cost per inference, and see, you can go ahead and again sort this and pick the one that best works for you. Okay, so in this case, for example, a P3.2 instance is too expensive, as you see here, sorted to the bottom. So that may not be the right option for you, although you may have been gravitating towards it because it has a powerful GPU instance. But turns out like a CPU instance or a G4 instance may work better for you. There are a number of other parameters that can also be tuned. In the environment parameter section, you can provide how many models to host on the same instance, but also how many CPU threads to consume and all that. I didn't specify them here, but you can specify all of these in the in the API as well, and you can see this in the Boto 3 documentation here, that you can specify a number of different things here. The stopping criteria we discussed, instance type, all of that is covered in the documentation. Okay, so that was a quick demo of SageMaker Inference Recommender, and as we discussed, it can automatically benchmark and tune and find the right instance for you based on your desired throughput and latency and traffic patterns, so that you don't have to spend days or weeks trying to figure this out manually, employing open source packages to go through and test all these different instances. So all of this is automatically available, and the integration in Studio means that you can take a look at the results and with a click of a button deploy it. So hope you enjoyed the video, and stay tuned for more deep dive on other SageMaker features that were released at reInvent, and I'll see you in the next one.